Okay, so I'm going to pause it there because we don't have, if you notice, that video is 13 minutes long, and we don't have time to watch it now, but I didn't do this on the recording, so let me put them in one more time. There are all three links that are on the board. So if you want to watch those later, you can. We're going to talk about all that stuff here today anyway. I teach a little bit differently on that last part than what Mr. Dowse, I guess that was his name, right? Dowse, I think is how you pronounce it. Then how he taught it, you get the same answer, but I just don't put the X in there because I find that tends to confuse students. But we're going to do the same concept that he's doing. So certainly if you watch that, it would be it's still going to be the same concept. He just goes about it a little bit differently than I do. Okay, so now this is what he was referring to. So you saw that on the video, a little preview of this. These are called special right triangles. So 5.05, 5.06 are going to be all about these two triangles here. And what makes them special are the angles inside. So like Mr. Dowse was talking about on that video, he was just talking about a 30, 60, 90 triangle. So those so if this was 29, 61, and 90, all this would get thrown out the window. You can't use this. Okay, so it has to be exactly 30, exactly 60, and the 90 is implied because it's a right triangle. Okay? And then the other special right triangle we'll learn about is 45, 45, 90. Now, also on this screen, you can see that sometimes you'll see an A. On the video we just watched, he used an X or S. Any letter will work. Okay, and like I said, it depends. We'll see how it goes. Sometimes I explain it a couple different ways so that it's less confusing. All right, so what we're going to do is I'm going to show you how these ratios work. Now the first thing you want to know for a 45, 45, 90 triangle, like the one we have on the screen, is what the ratios are. So the ratios are 1, 1, square root of 2. So sometimes you'll see it written with the dashes in there. You could also have the dots in there since it's a ratio. That's the ratio of the sides. And all that refers to is the coefficient in front of the A. So you can see here on this picture that it's just A, or could be X, something like that. Doesn't matter what letter you use. But the coefficient in front of each of those is actually a 1. And so that's where the 1, 1, square root 2 comes from. Okay. Now one thing that students at first you'll have trouble with is remembering where those go. But what I want you guys to do, probably some of you know this off the top of your head, tell me what the square root of 2 is. Or if you're not sure, grab your calculator. Tell me what the square root of 2 is. You'll need your calculator probably anyway here in a few minutes. So tell me what the square root of 2 is. Yeah, it's approximately 1.41, okay? So if I wrote this out in decimal form, it'd be 1.41. So see how 1.41 is the largest out of those three numbers, right? See, we've talked before. Nice, Tara. Tara has everything in there. We've talked before how the longest side has to go across from the largest angle. Okay, he was talking about that in the video too, and that will really be a good guide for you on these special right triangles. So since the hypotenuse, which is the side across from the right angle, is always your longest side, the square root of 2 has to go over there on the hypotenuse because it's your longest ratio, okay, your largest ratio. And then it makes sense because if we have 45 and 45, this is really an isosceles triangle, which means both of those legs should be the same length, right? So it would make sense that they're both the ones because that's the only way you're going to get them to be the same. Does that make sense how you would figure out where these ratios go? Okay, got 3 S's, so that's good, and we'll practice some. So that's always the key, right? Sometimes it'll sink in, it'll make sense, and then you start doing some problems, and you're like, okay, I think I missed something because none of these answers are coming out correctly. So, oh, weird, Amelia. It's been doing some strange things. It's kind of, I mean, it's a really small class today, so maybe you're not the only one having issues. I've had students on and off the past couple weeks telling me that, so I don't know. I know there was an update recently, so I don't know. Who knows? But anyway, I'm glad you're in. That's awesome. Okay. Haha. Yes, knock on wood for sure. Okay, so how do we use this? Well, let's say, let me see what I have on this. Okay. Let's say on this screen here. Let's say that I told you that you knew this side was a length of 5. Okay, and I said, find the other two sides. So up to this point, you don't have, well, let's think through. Let's think about our right triangle tools that we have. So we have Pythagorean theorem. That's one right triangle tool that we have. Would Pythagorean theorem work in this case if all you knew was one side? If you knew this was 5 and that's it, could you find this side and this side? Now probably with these ratios up here you're thinking, yeah, I could find this side over here. Okay. So yeah, the 45 is a little easier. You could, if you realized that, oh hey, this is an isosceles triangle, you could figure out, oh, that's 5. So I at least know 2 sides. I could find the third side using Pythagorean theorem. So that is possible and doable. Okay. This though is still helpful because one, let's say for example that I moved this 5 over here. Let's put the 5 over here. Let's say the 5 is the hypotenuse. Would you be able to use Pythagorean theorem in that case to tell me what the 2 missing sides are? Not in that case. That gets a little harder, right? Because what do you have to know to use a squared plus b squared plus c squared? If I had this case where all I know is the hypotenuse, that means all you know is c. You don't have a or b, right? Now if you think through it, you could figure it out because a and b are the same. So it is possible. However, the nice part about this is you're still going to be able to get this a lot faster. Okay, it's only 3 numbers that you have to remember, so that's not hard at all. And then once you get the process down, these are going to be super fast to find. Okay, so it's faster than Pythagorean theorem. And the reason that we learn these is these are common triangles that appear a lot. So like I was actually just looking at building the swing set for my kids. And so if you do, construction or woodworking, this triangle is useful to know. Okay, so this could be one place you might have this pop up. Okay. Good. So let's talk about that. Okay, so how do we get this? Well, what we want to do is we want to label the ratio on each side. In this case, we've already done that. We have 1a, square root of 2a. And because the 5 and the square root of 2a are both on the hypotenuse, they have to be equal, right? Does that make sense? If I have something, this side is labeled in 2 different ways, those 2 things have to be equal. There's no way that this side can be 2 different amounts, right? Does that make sense to you guys? So in other words, what I'm saying is 5 and the square root of 2a have to be equal to each other. Okay, so that's what you want to do. If you label your ratios, you just take a look at your triangle and say, okay, what side do I already know? So in this case, I already knew the hypotenuse. We'll just make those 2 things equal. They're both on the same side. They have to be equal to each other. And then what you've created is a little algebra equation. and it's not a hard algebra equation. I want to solve for a, so I divide by the square root of 2. And so over on the right, those have canceled out. Oh, okay, hold on. Okay, let's see if that helps a little bit better. Okay. So we were in the process of solving this algebra problem. So does that make sense how the square root of 2's would cancel out and we just have a. And then 5 squared root of 2, what we want to do, I know you certainly can put that in your calculator, okay? You can take 5 divided by the square root of 2 and put it in your calculator. So that's, yeah, that's what Mason had. You already had that figured out for us, Mason. 3.54, right? Okay. Oh, is it 2.5? Well, let's see. 5 divided by the square root of 2. 3.54 is what I got. Why would, I don't know, I'm missing what you're thinking there, Mason. Why would the 5 be squared? Oh, I see. Well, you don't have to square each side because this one's different. So if there was an x under here, so the square root of 2, it's only over the 2. Okay. One way to eliminate that confusion, and actually what is better than what this picture is showing, instead of the square root of 2 times a, we usually write the a first and then the square root of 2. That way it's a little clearer to see that the a is not actually underneath the square root. So sorry about that. That might have been your confusion. Okay, well, let me fix that. That might be a good clarification to make. So let's say it was 5 equals a times the square root of 2. Square root of 2 times a times square root of 2, they're the same thing, right? But this does make it easier to see that the a is not under the square root. So I'm going to do the same process. I'm going to divide by the square root of 2 on each side, and that square root of 2 will cancel. So that's why I don't have to square each side, because my a, the square root of 2 is just a number. So like, for example, if this was 5 equals a times 2. Well, okay, so yes, Mason, what we're doing here, you don't have to use the Pythagorean theorem. You could, but this strategy is different. So what we're doing here is we've learned that there are, if you have a 45, 45, 90 triangle, the sides are always in this ratio up here, 1, 1, square root of 2. So what we're doing, and this was back in chapter 4, if you guys remember, using ratios, it was multiplication or division involved, right? So that's the strategy that we're using here, and so that's why we aren't squaring or square rooting to find our variable, okay? So here we get a equals 3.54. So yeah, like you proved, Mason, you could do this particular question using Pythagorean theorem if you had to. Now, when we get to the 30, 60, 90 triangle in a second here, that actually gets a little harder. You really can't use Pythagorean theorem on that one. This one's not, you know, a little more doable because 2 of the sides are the same. Okay, but what we want to do is get used to how this works, because the concept is going to work. The ratios are different because there's different angles in the 30, 60, 90, but the concept is going to be the same. Okay. Yes, we sure can, Anthony. We're not quite done just yet because what we have to do, and it's not a hard thing, but we do have to just make the extension to realizing, oh, okay, that would be the length of each of these sides because it's equal to a. A is 3.54. That means each of these legs are 3.54 because that they are a. They're equal to a. Okay. Now the other thing that you might see, so I'm preparing you for whether you have multiple choice or whether it's part 2, you want to be able to do both. Give this answer, you want to be able to see this answer multiple ways. So the thing that you might see, besides 3.54 as an answer choice, you might see this. 5 square root of 2 over 2. Okay, so this and this are the same. Now, there's a couple different ways you could match those up. Okay. Right, Anna. So if you had two sides of a right triangle, you can always find the third side. But when we get to the example, I'll show you that we can actually solve the triangle only with one side using these ratios. So hang on just a minute. But that's the advantage to these. That's why we learn them, because you can have less information but still be able to solve it. Okay, so how I got there, and this is going back to algebra, which we don't, it's like one lesson usually in algebra. So I know it's probably a little bit back there in your memory, but we'll work on pulling it out. What you do is we take this answer of 5 over the square root of 2, and the square root in the denominator is just not proper math. We just don't leave a square root in the denominator, so we need to get it out of there. So what we do is we multiply. It's a clever little trick. We multiply the numerator and the denominator by the square root of 2. And that's allowable because the square root of 2 over the square root of 2 is just what? So we're not changing the fraction, because what is this really equal to? Yeah, it's really equal to 1. Okay, if you have something in the numerator and the exact same thing in the denominator, it's really just 1. And multiplying by 1 means you're not changing this fraction. We're just going to make it look different. Okay, so it's a neat little trick. So what ends up happening in the numerator is we have 5 times the square root of 2 in the numerator. And what's the square root of 2 times the square root of 2? The 2 comes out. Okay, so let me show you the work down here. The reason is because you write square root of 2 times square root of 2, you can combine it like that. And then remember, if you have a pair underneath the square root, it comes out in front, and you don't need the square root anymore. So that would equal 2. Oh, that's okay, Nathaniel. Thanks for letting me know. I was wondering if maybe you were having trouble with Illuminate as well, because Amelia was. So I thought maybe that's the problem, but that's okay. We had it on record, so you can go back and catch what you missed. Okay. Oh, sorry, Amelia. That is frustrating. Now, the other way that you can figure out, so let's say that this is the answer you got. You changed it to decimal, and you're looking at the multiple choice answers, and you're like, oh, no, there's not a 3.54. And then you're like, oh, I know Mrs. Williams showed this to me, but gosh dang it, I forgot it, and I'm in the middle of a quiz. Okay, so what you can do is you can plug the answers into your calculator. Okay, so you can take 5 times the square root of 2 divided by 2, put it in your calculator, change it to a decimal, and just keep going down through your list until you get the decimal that matches. And then you know that's the right answer. Okay, so a few different strategies. But hopefully that won't happen to you. Hopefully you will remember this. Because this will come in handy too. When you guys get to Algebra 2, you'll have to do this. So the sooner you get it down, the better, right? Just less stuff to learn later. All right, let's do another example. Let's say, and actually, real quick, let me fix so that we don't get confused. I'm going to fix this ratio over here. I'm going to change it to a square root of 2 instead of square root of 2a, just so we are consistent there. Okay, so there are our ratios. Okay, so remember, well, you guys tell me. Can you tell me how I would know to label that triangle with those ratios? So if I didn't already have that labeled, how would I know I could do a square root of 2? Man, there is some lag, huh? But yes, I see 2 answers typed in there already, and that is correct because of the angles in there. Okay, so just remember 1 square root of 2, and remember that the square root of 2 is going to go across from the hypotenuse because square root of 2 is bigger than 1. All right, so let me give you another example. Let me give you two examples. We'll do these in different colors. Let's say I told you, anybody want to try these on the board? Raise your hand. Let's say for the first example that I told you that this leg was 10, and I asked you for the others. All right, so Anthony can take this space, and he's going to do the green problem. And Anna, let's say I told you this side over here was 20, and I said find the others. Okay, so I'll give you the space over here on the right. All right, let me give you guys whiteboard privilege. All right, go for it. See if you can find the other two side lengths. And you guys, if you're watching, don't just watch. You try it yourself. Okay, hang on one second, Anna. Careful. We don't know. What do you know? If we have 20 right here, is that equal to A? Think about what if the 20 and the a squared of 2 are both on the hypotenuse. Is A 20? Think back to that last problem. What did we do with the 20 and the a squared of 2? If they're both on the hypotenuse, what do you know about these two things? Yes, there you go. So you want to say a squared of 2 equals 20. Good. And yes, Anthony, yours looks good. Let me, yeah, 14.1. Now, again, you want to be able to do both versions of this answer. So you might see the answer left as 10 squared root of 2. And we don't have to do anything to that one because the square root in the numerator, that's okay. So there's no fraction there. There's nothing that we need to do with that square root. We can just leave it. 10 times the square root of 2. Or you could also see 14.1. So that is actually it, Anthony. If you have the side A, it's actually pretty easy. So this would be 10, this would be 10, and this would be 10 square root of 2. That's really simple, right? Now Anna's version is a little harder. Okay, so she's doing the purple answer. The purple answer is if you have to do a little more work, but this is the key. What Anna is showing here, just think through it. If the 20 and the a squared of 2 are both on the hypotenuse side, they have to be equal to each other. So you want to show that in an algebra problem that they're equal, and then you'll solve for A. Looks good, Anna. Keep going. Yes, Anthony. So what I was saying was 14.1 is also acceptable. So you could say 10 squared root of 2 or 14.1. I just want you to be comfortable with each of those. Oh, I think you're saying for the purple. Yeah, this didn't happen. This was just a coincidence that A for Anna is also, let's see, 20 divided by, yeah, so it ended up being 14.1 as well. Now, again, the one thing here that I would just have you guys be careful with is you can use the square root of 2 and instead of changing it to 1.41 and you can work with the square root of 2, I would try to practice that, you know, just to build up your skills. But what you did here is also correct, Anna. So that would be, notice how this is A is 14.1. And that would be the legs, because each of the legs are equal to A, right? So you have 14.1, okay? So that would solve it for both the purple problem and the green problem. Okay. Yes. So let's do the square root version as well. So if we did the square root, if we kept the square root in there, we would divide by the square root of 2. And I know it looks crazy, but the square root of 2 is just a number. You guys, you know, can put it in your calculator. You get 1.41. So it has all, you know, the same rules apply to the square root of 2. So we get A equals 20 divided by the square root of 2. And then we want to use that trick where we multiply by the square root that we're trying to get rid of. So the best way to write this answer would be 20 times the square root of 2 all over 2. So don't forget that that might also be this answer for A. Okay? All right, let's try a 30, 60, 90. Now the idea is the same. The ratios are a little harder to remember on this one. So we have 1, 2, square root of 3. Oh, and I don't know what happened to this slide here. This is strange. This is like, I don't remember putting this on my slide. So let's get rid of that. Okay. So 1, 2, square root of 3. So this might be, maybe this would be how your problems will look. Okay. So let's say I told you that this side over here is 5. Okay. So it doesn't look like you have too much information there, right? And here you could use trig. You could use sine, cosine, or tangent, figure out which one would work. You could do that, okay? Same thing on the 45, 45, 90. You could do that also. However, this one is going to get you there quickly if you can remember the ratios and remember where they go. So where do you think the 1 would go? This, let's see, do they have it broken apart? It's for 5.05 and 5.06. I don't remember. Let me look. I think they break it apart maybe. One lesson is the 45, 45, 90, and one of them is the 30, 60, 90. I'll look here. Yes, good, Mwada. That is correct. So the 1, she's saying, okay, it's going to go across from the 30 because the 1 is the shortest side. Okay? What about the 2 and the square root of 3? Which one of those is bigger? And I'll just add an A. This is our ratio, 1A over here. Yeah, you're right, Nate. The 2 is bigger, so the 2 is going to go across from the hypotenuse. So this is going to be 2A. And then the square root of 3 goes across from the 60-degree angle. So A times the square root of 3. Okay, so that's the same idea as the last triangle, right? 45, 45, 90. You label the sides first with the correct ratio. Okay? Then, remember the second thing we did was we took a look at what information we already knew, and we set those two things equal to each other. So the 2A and the 5 have to be equal because they're both on the hypotenuse. They're two different ways to represent the hypotenuse, but they have to be the same. And the 5 have to be equal because they're both on the hypotenuse. They're two different ways to represent the hypotenuse, but they have to be the same. So using algebra, that means 2A is equal to 5. I'm going to divide by 2 on both sides to figure out what A is. So it would be 2.5. Okay. Okay, so help me fill this in. What would I have here? What would I put? What's the side across from 30 going to be equal to? Yeah, it's just 2.5 because this is A. We figured out A is 2.5 and that's what this side is labeled. So that's easy. Not much work to do there. And then over here, again, since I know A, really I'm just plugging it in. I'm taking 2.5. I'm going to plug it in. So I get 2.5 times the square root of 3. Yeah, and in that case, we probably would change it to just a decimal. We'd put that in our calculator and multiply. So 4.33. So we have 4.33, 2.5, and 5, which we knew to begin with. Those would be our 3 side lengths. Okay? Okay, let's try one more. Again, let me take out those. Okay, so do you guys remember, let me give you all whiteboard privilege, write down the ratios. What are the ratios for a 30, 60, 90 triangle? Good, Emma. Yep, 1, 2, square root of 3. Perfect. You guys got it on the board. Nice. Okay, and if you guys are writing on the whiteboard, label underneath there what angles those are going to go across from. So what angle does the 1 go across from? What angle does the 2 go across from? Good. Good. Yep, there we go. So again, the smallest angle, the shortest side should go across from that. 90 is the biggest angle, and 2 is the biggest ratio, so those have to go across from each other. And the square root of 3, if you put it in your calculator, it's 1.69, so it has to go across from the 60. Good. Excellent job, guys. Okay, now let me give you a problem to complete. And if you guys want to do it on the board, go for it. Let's say I told you that this side over here was 7. Tell me the other 2 sides. Good. So you can see in the green there, Anna is filling in, or she's adding the A there. Or it could be X, just some letter. Because remember, ratio means that's not actually what that side equals to. It's equal to 2 times something. And it's equal to 1 times something. And it's equal to the square root of 3 times something. So you want to put an A in front of that square root of 3 also. Okay, and then what do you do? How do you get started with this? Because this is usually the place where you'll get stuck. So if you can think through this now, that should set you on a pretty good path for your homework and your quizzes. So after we label the sides, what do? You're kind of like, okay, we got, no you don't. You do not give up. You got to keep trying. Okay, you're right. We're going to solve something. Yeah, there you go, Anthony. That's what we're going to solve. We want to set the 7 and a square root of 3 equal. Yeah, sounds like sauerkraut, huh? We're going to set 7 equal to, now, what if I wrote it like this? 7 equals the square root of 3. Does that make sense? Is that quite right? I'm missing something there. What is it? Not quite right, because 7 and the square root of 3 are not actually equal. Those are 2 different numbers. We need an A. Because if we take the square root of 3 times something, then it would equal 7. But 7 and the square root of 3 are not the same thing. Okay? Yes. Give me an A. That's right. Okay, so now we're going to solve. How do we solve that? We want a, not the square root of 3 times a. So now what do we do? Okay, I think that sounds right, Emma. How'd you get that? What did you do? Good. You want to divide by the square root of 3 on both sides. Okay. Good, good. I like that Anthony's doing that part in gray there. That looks good. So divide by the square root of 3, and over here it's going to cancel out. And then over here you have 7 divided by the square root of 3. So let's see if we can, so yes, 4.04 is the decimal of that. What if we don't change it to a decimal and we want to write it with the square root in there? Can you guys do that? Okay, so show me on the board. How would we do that? Well, that is true, Nathaniel. It does equal 7 square root of 3, but if we have square roots in the denominator, we want to rewrite it so that the square root is not in the denominator. So what would we multiply the numerator and denominator by to get it out of there? What do you guys think? Good. Yes, the square root of 3, because what's going to happen if we do that, so if we have 7 over the square root of 3, if we multiply by the square root of 3 on the top and bottom, we're not changing the fraction, we're still just multiplying by 1. But in the bottom, when you have two square roots that are exactly the same, it breaks that stuff out of the square root. So we just have 3 down there. So this would be a. Okay? So this side down here would be 7 square root of 3 over 3, or 4.01, or 4.04, sorry. Okay, so that's the decimal version and the fraction version. Okay? We have one more side to find, right? We got to find the hypotenuse as well. So you could take 4.04 and double it, multiply it by 2. Yeah. To get 8.08. Okay, so that's the decimal version. If you take 7 times the square root of 3 over 3, and you multiply it by 2, yep, that's right. It's just the 2 and the 7 that get multiplied. So it becomes 14 square root of 3 over 3 is how you'd simplify that. Okay?